Welcome to lecture number 68, and today we will start some new topics. And if you recall that in some previous few lectures we have discussed about the graph theory applied to network analysis. I have only considered I have not really discussed about graph theory in great detail. It is a different subject in its own right, but just the relevant portions which are necessary to solve network problems, that I have discussed. You must understand there are various properties of A matrix, B matrix, this, that we are not going to discuss in the network analysis problem. But one good thing is that in graph theory what happens, this graph theory is looking at the graph of a network and the directed graph, we can easily identify, oh, this can be associated with currents and these are the node voltages, things like that. And there may be of course situations, for example, in this case Y matrix is like this 1 by 2, things like that. It may so happen between two nodes there is no impedance connected. Suppose an ideal battery is connected across A and B, then the value of Z, Y will be infinitely large. In such cases, okay, that Y matrix or the nodal analysis I can avoid and I can apply the Z matrix. Z matrix will be finite, Z is equal to 0 if there is an ideal battery across AB. Similarly, there may be a current source only connected between two nodes. In that case, Z matrix will have infinite value and you cannot proceed further. In such cases, nodal approach will be appropriate. There are techniques you can, if there are voltage source, ideal voltage present between two nodes, that can be transferred to other nodes and try to solve the circuit. Those are the things, if time permits, I will discuss one day, but that is not the big issue. Big issue is you one of the approaches you can adopt. After all, for a large network you are going to do it, you can write your codes. The formation of Z, Q or A matrix is very simple, that is what you have to do. Then you enter those data, then solve this equation, or in other case equations involving loop impedance matrix or nodal impedance matrix. Anyway, you solve problems, small problems on that. Now, today I will be telling you, okay, there may be circuits. Till now we have considered circuits or networks having independent voltage current sources. That is, any source present, they are independent. What do I mean by this term independent? It means that whatever parameters are connected in the network, R, L, C, this, that, the terminal voltage, if it is an ideal voltage source, is independent what you are connecting across it, that will remain independent. Similarly, whatever current sources are connected in the circuit, if it is an ideal current source, the current in that branch is independent of what you are connecting in other branches, or it does not depend upon that parameters which we have connected to form the network apart from the sources. So, that is why those sources are called independent voltage or current sources. This is in fact we have done that, but there may be circuits where the for example, if I draw it, you will understand it better what I mean to say. Suppose you have a network like this, here is a current source, here is another voltage source like that. Okay. So, these are the symbols for independent sources, say E1, E2, or this is say some current source. These parameter values are known. Now, what I am telling is, no matter what is the value of R1, R2, R3, mind you, I am writing resistances in S domain, you can write it E1S, E2S, R1S, Z1S, Z3S, Z2S. I think you know this now. Now, so these sources E1 is an independent source, because no matter what is the value of R1, R2, R3, this voltage between these 2 points is going to be E1 always. Similarly, this current in this path will remain I no matter what is the value of R1, R2, R3 or Z1, Z2, Z3. That is why they are called independent. So, independent sources are generally drawn in the circuit with these independent sources. They can be AC, DC, what not. They can be, if it is a small battery, it will be shown like this, E, independent source, or a big DC supply, that is generally shown by a circle, and this one say 100 volt DC, is not. These are the representation of independent sources, and there may be AC voltages. These are the representation of independent sources. Now, the question is, what are then dependent sources? To tell verbally, a dependent source is in a network which might have several branches, several nodes, etc. If suppose I say that in one of the branch there is a voltage source whose magnitude depends upon current in some other branch. Okay. Similarly, current in one branch may depend upon the voltage in some other branch. Then those sources will be dependent sources. Let us take a simple example to explain the idea. Suppose you have a network like this. This is the symbol for independent source. This is suppose R1, and this is suppose R2. This is another source here. There is and maybe a current source there. These are independent sources, but I may say that current in this branch, this one, what I will do is this current, whatever is the magnitude, whenever it flows, there will appear a voltage in this branch with this polarity, the value of which is k into I. K is a known constant, maybe 2 I. Got the point? Therefore, this one is a dependent voltage source. Dependent voltage source. the unit of K will be volt per ampere. So, that this becomes volt. So, a dependent voltage source will be represented, all dependent sources will be represented by a diamond like this, and the voltage across this one will may depend upon current in some other branch of the circuit, for example, K I 1. What is I 1? I 1 is current in some other branch, a definite other branch of the circuit. When I 1 flows between these 2 points, a voltage K I 1 will appear. Or another dependent voltage source may be plus minus the voltage between these 2 points will depend upon voltage across some other branch V 1 maybe. So, in that case K will be unitless, and what is V 1? V 1 is the voltage in some branch number 1, whatever it is, that will be very clearly specified. So, this dependent voltage will be marked with polarity with a diamond shaped thing like this, and the relationship that is what is the magnitude of the voltage will be also clearly written. So, that you know what it is on which. So, naturally the voltage between these 2 points will depend upon voltage in some branch which is V 1. It simply tells that. So, similarly, you can have a current source, current dependent source, which will be also represented by diamond shaped like this, but this time the polarity, instead of that, the direction of the current will be mentioned. So, these are dependent voltage source. Representation I am talking about, dependent voltage source. Similarly, dependent current sources. Will be represented like this. So, magnitude of this current may depend upon some current in other branch. In that case, K will be dimensionless, or dependent current source here the magnitude of this current with the direction specified, as we have specified clearly the voltage polarity, it may also depend upon some voltage in some other circuit, other branch. Understood? So, there may be some sources which is not neither a ideal battery or a current source, as we have dealt with earlier, and those are called independent sources. They now in some branch these voltage or current sources, if they are drawn, it may depend upon some value of current in some other branch or value of voltage in some other branch, but clearly this polarities will be mentioned and things like that. For example, now why do they come into, why we are interested to know how to solve circuits which are having both independent and dependent sources. What is the reason for that? Reason is there are situations, for example, in a mutually coupled coil circuit, if at any time this voltage is V 1, if it is transformer, the voltage between these 2 points will be V 1 by N 1 into N 2. N 1 by N 2 is a constant. Therefore, here suppose you have connected a voltage source which is V 1, that is why this voltage has become V 1. then the potential between these 2 points gets fixed because of this thing, say transformer, ideal transformer. Similarly, when a current is delivered here I 2, the current in this branch drawn from the supply gets fixed by this current I 2, which will be equal to I 2 by N 1 into N 2. Got the point. So, here we can assume there is a current source in series with this. So, this is for mutually coupled coil. Similarly, there may be situations, for example, a transistor, common emitter transistor operating in active region, the collector current is beta times the base current, is not like this. For example, you have a circuit like this. This base current beta and this collector current here plus VCC etcetera, this current is beta into IB, if the transistor is in the active region, and this magnitude of the current is not dependent upon what is the value of RC. So, current in this branch is fixed by the base current beta times that, beta is that transistor constant, that is the amplification factor of the between collector current and base current. So, collector current I C will be beta times the base current. So, there may be situations like that. We are not discussing those circuits, but in general what we will do you tell you is this, that okay, in a circuit, if a circuit is given with both the dependent sources and independent sources present, then how to analyze those circuits. That way I will introduce to you, and nothing is better than take an example for, because we know already how to analyze a circuit problem. So, in the same way we will go, we will write down KVL, KCL or whatever method, maybe Thevenin's theorem to find out currents in various branches or nodal method. So, here it will be, so I will explain this whole thing by considering a network problem where both dependent and independent sources are present, and would like to find out the currents in the circuit. So, let us take one example. For example, I take this simple network, which is suppose I give you a network like this. Here is a resistance, here is a voltage source 10 volt. Is this a dependent or independent source? It is independent source. This is the how it is specified. This is suppose a 6 ohm resistance connected 6 ohm, and here I show it with a different color. Here it is shown like this. Okay. And then you have a resistance connected here, say 2 ohm. So, 2 ohm, 6 ohm and this is 4 ohm given, and it is given to be a voltage source. So, this is dependent source, this one. Who tells me that? This symbol, dependent source, dependent source. And now, on what thing the magnitude of the, is it a voltage or current source? It is a voltage dependent source, it will be a voltage source. dependent, depends on some currents or voltage in other parts of the circuit. Suppose it is given that whenever this current is I 1, the magnitude of the voltage is 2 I 1 here. Okay. So, this is well defined circuit now. Now, suppose I say that I want to find out the currents in various branches of the circuit. So, there is a dependent voltage source, there is an independent voltage source like there. Now, how to find out the currents? These calculations will be pretty simple. In various ways you can do, because I know how to solve a network. I will treat this while writing down the equations as a voltage source of magnitude 2 I 1 and so on. Now, the point is how to solve it. There are various ways of solving this network, and first let us see that in this network, in this outer loop, there is only one unknown I 1. I have to form one equation involving I 1. If I can do that, my problem is solved. So, consider this loop and try to write down the KVL in that equation. Got the point? So, how to do it? Let us assume this current to be I 2. If this is I 2, the current in this branch will be I 1 minus I 2. So, what I will do, I have to actually two unknowns are there, I 1 and I 2. So, I take this outer loop or any loop you take, outer loop suppose I take. Then I start from this point, from this to this, what will be the voltage drop here? Plus minus 4 I 1. So, 10 volt, from this to this 10 volt, then minus, if any mistake point out, minus 4 I 1. Then I reach this point, and then from this to this, it is a voltage source with this polarity. So, minus 2 I 1. I reach this point, and the voltage between these 2 points is 2 I 2, is not, with this polarity. So, minus 2 I 2, and I have come back to this point, no drop here. So, that is equal to 0. So, one equation is therefore 6 I 1, take everything on the right hand side, plus 2 I 2 plus 2 I 2, and it is equal to 0, is equal to 10. This is equation 1. My goal is to solve for all the currents in various branches of the network. So, that is the first equation. Second equation is, I would like to develop another equation which I can do that any loop, this loop will also do. So, I write down the KVL equation in this loop. What will be the KVL equation in this loop? So, this will be once again 10 volt minus 4 I 1, then I come here, this will be minus 6 I 1 minus I 2, and you reach this point, and this is equal to 0. This is equal to 0. I 1 minus I 2, clear. So, this will be 0, which is equal to, or this one is 10 minus 10 I 1 plus 6 I 2 minus plus 6 I 2 is equal to 0, or you get minus 10 I 1, this equation I am writing here, minus 10 I 1 plus 6 I 2 is also 10. This is equation 2, is not. Therefore, I will be able to solve these two equations. So, equate these two, you will get the relationship 6 I 1 plus 2 I 2 is equal to minus 10 I 1 plus 6 I 2, or 16 I 1 is equal to 4 I 2, is not. To you take to this side. So, therefore, 4 I 1 is equal to I 2. Then use any of these equations. For example, I 2 you substitute. So, you say 6 I 1 plus 2 I 2, 2 into I 2 means 4 I 1 is equal to 10, or you will be getting 6 plus 8, 14 I 1 is equal to 10, or I 1 is equal to 10 by 14 is equal to 5 by 7 ampere. If I 1 is this, then I 2 is equal to 4 I 1, and that will be 20 by 7 ampere. So, I have been able to solve the circuit, all the branch current, etc. Did I apply any new theory? No. I applied simple KVL, KCL and so on. If I wish, I could also apply nodal analysis. For example, I say that this point is O, this point is A. Then also you can write at A, KCL will be V A 0, potential of A with respect to O, O is reference point, minus 10 divided by 4 plus V A 0 divided by 6 is this one, and plus current in this branch. This current will be, potential of this point will be V A 0, then to potential of this point with respect to O will be V A 0 minus 2 I 1, and then that voltage appears across 2, that is 2, this is equal to 0. This is one equation, and the other equation is V A 0 and I 1, you write some loop equations. For example, V A 0 and I 1 can be related here, and similarly the other equation you write down KCL, and you see that V A 0 by 6 is nothing but I 1 minus I 2 and so on. So, same results you will get at the end, but what I am telling you can apply nodal analysis. You complete this problem with this method, got the point, and you will get the same result. So, what is the current in this branch? Suppose this is the load resistance, this current is I 2 and I 2 is 20 by 7 ampere. You note it down, 20 by 7 ampere will be flowing here. Then you have solved for I 1 also, that is 5 by 7 ampere, and then I 1 minus I 2 I can calculate and get this current. Is that clear? 5 by 7 ampere, 20 by 7 ampere is there. So, you can solve this network by any method you like. Now, so here is a voltage source which is independent, and here is another voltage source which is dependent, and it is telling that the magnitude of the voltage with this polarity across this, whenever I 1 flows, this magnitude get decided with this polarity plus minus. That is all, otherwise nothing very complicated situation like that. We will, so it is better you only I will give you some circuits in my next lecture and tell you how to solve those network problems having both dependent as well as independent source. Thank you.